The marvel of electricity. Has it ever aroused your curiosity? What are the processes involved in producing the electricity that powers our day-to-day activities, illuminates our nights, and keeps us connected? Today, we are going to embark on an in-depth exploration of this fascinating subject. We will unravel the intricate processes behind the production of electricity, delving deep into the heart of this vital force that underpins our modern lives. To begin with, we need to acknowledge that a significant portion of the world's electricity originates from generators. A marvel of human ingenuity, these devices are tasked with the crucial job of transforming mechanical energy into electrical energy. The underpinning principle that makes this transformation possible was discovered by none other than Michael Faraday in 1831. Termed as the electromagnetic method, this principle sheds light on a complex interaction between magnetic fields and electric circuits. To break it down, the electromagnetic method postulates that any change or shift in a magnetic field in the proximity of an electric circuit induces a current in that circuit. This shift could take on several forms. It could be a change occurring within the field itself, the movement of the point from where the field originates, or even the motion of the circuit within the field. Thus, the magic of electricity production lies in the transformation of mechanical energy into electrical energy, a mesmerizing dance of forces that gives birth to the power that fuels our world. But how exactly does this conversion from mechanical energy to electrical energy happen? The primary source of this mechanical energy is steam. Now, let's break down the process more in depth. Initially, water is heated by coal, oil, or gas. This results in the formation of steam, which is an incredibly powerful force. This steam is then carefully directed towards a turbine. As the steam hits the blades of the turbine, it forces them to spin. This spinning of the turbine is the first step in generating electricity. As the turbine spins, it simultaneously rotates a magnet. This magnet is set near an electrical circuit. As the magnet revolves, it disruptively interacts with the electric circuit, generating a ruffled current. This disturbance in the circuit is what initiates the flow of electrons. The movement these electrons creates what we comprehend as electricity. This flow of electrons is known as an electric current, the basis of electricity. It is this specific process in which mechanical energy, derived from steam, is converted into electrical energy. And thus, the invisible force we refer to as electricity is brought to life. However, there's an alternative, eco-friendlier method to generate electricity: green energy. Green energy, the earth-friendly substitute, is procured from sources that don't directly emit pollution. Consider solar, wind, nuclear, or water energy. These methods are not just gentler on our planet, but they also function using the same principles as traditional electricity generators. To elaborate on this, let's start by examining the conventional way electricity is produced. Traditional power plants burn fossil fuels like coal and natural gas, or use nuclear energy to heat up water, which then turns into steam. This steam is used to spin a turbine, which is essentially a large wheel with blades. The steam hits the blades of the turbine, and the force of this blows the blades around, creating a rotational movement. This rotation is the mechanical energy. The turbine is connected to a generator which houses a large magnet and a coil of wire. As the turbine spins, it rotates the magnet inside the coil of wire. This movement creates a magnetic field that induces an electric current in the wire. This is how mechanical energy, the spinning of the turbine, is converted into electrical energy. Instead of steam pistons rotating the turbines, it's the might of wind or the force of water currents taking up the task. Imagine a windmill whirling in a windy field or a water wheel revolving in a flowing river. These natural forces can rotate the turbines, which then generate electricity in the same manner as steam pistons would. So, be it the power of steam or the force of wind and water, the wonder of electricity is omnipresent.